Welcome back. We are focusing on Module 10 today, which is quantifying variability relative to the mean. We have been working with measures of center with the median and the mean. And in the last section for Module 9, we worked with a 5-number summary and the interquartile range as a measure of spread. Today, we're going to learn a new measure of spread called the standard deviation, which is working with the mean instead of the median. In this section, you'll note that we're doing a lot of calculations by hand. But in reality, in our class, we're going to be using StatCrunch for these calculations. It's important to understand what's happening when we perform these calculations, which is why we're going to do them by hand now, so that you understand the process of how the standard deviation is calculated. All right, let's get started. A deviation. What is a deviation from the mean? When used deviate in the real world, it's to go off in a different direction. So the deviation from the mean is how far a point is from the mean. We calculate this by taking the difference, subtracting, of the point from the mean. So we find the difference between the data point that we're talking about and the average of the data set. When you have a negative deviation, that means that the point is below the mean, because if you're taking, say, some value minus the average, whenever you get a negative, that comes from the first value being smaller than the other value. So if we're taking the value minus the mean, and this is negative, that means that the value was smaller than the average. Let's say I had a class average of 75 and I was looking at a value of 50. 50 minus 75 is negative 25, and that value 50 is less than 75. So a positive deviation is when the value minus the mean is positive, and that happens when your number is greater than the mean. We're going to look at a dot plot that is in the Learn by Doing in OLI. And we're told that the average is 9, and that's what this little line is here. That's saying that the mean is 9. That's the balancing point. Determine the deviation from the yellow point and the red point. So the yellow point is below the average, and so we should get a negative deviation. The red point is above the average, and so we should get a positive deviation. We calculate again by finding the difference. This point here is at the value of 3, and the red point is at the value of 14. So for the yellow point, we take 3 minus the mean of 9, which is negative 6. That's our deviation, 6 below the mean. The red point, we have 14 minus 9, which is 5. So that deviation is 5 above the mean. We have the exercise mirrors problem from page 47 of OLI that we're going to work on. We have a data set. The data set has the numbers 2, 3, 4, and 7, and we're asked to calculate the mean. Remember, to find the mean, we add all of the numbers and divide by however many numbers there are in our data set. That's found by taking the sum of all of the x values divided by the sample size, which is 2 plus 3 plus 4 plus 7, divided by 4 because there's 4 numbers in the data set. That's 16 divided by 4, or 4. So the average for this data set is 4. Now we're going to calculate the deviation of each of these points. Where are these points in relation to that middle value? So we take 2 minus the average, 3 minus the average, 4 minus the average, and 7 minus the average. And that will calculate our deviation, how far each value is from the mean. 2 minus 4 is negative 2. 3 minus 4 is negative 1. 4 minus 4 is 0. And 7 minus 4 is 3. We're taking the first value minus the mean of 4. On the next page, we are asked to sum these values. what is the sum of these four values? What is the sum of -2 plus -1 plus 0 plus 3? -2 plus one more negative is -3. -3 plus 0 is -3. And -3 plus 3 is 0. The next question we are asked is, will this always happen? Are your deviations always going to add up to 0? And the answer is yes, because the mean is a balancing point. Remember from the last section, we learned that the mean balances the distances. So the distances below and the distances above, the deviations are always going to cancel each other out and be 0. Because the mean balances the distances, finding the deviations and adding them up gives us no information into how spread out our data is. So we need to do something else. What we're going to do is we're going to find the absolute value next. Let's see how that works. The data value, 2, 3, 4, and 7, we calculated the deviations in the previous section. We had -2, -1, 0, and 3, because remember that the mean was 4. And where is that number in relation to 0? The absolute value of a number is the distance of that number from 0, and absolute value is never negative because distance is never negative. You run a mile one way, that's a mile. You run a mile in the other direction, you've just changed directions, but you're still going another mile. The absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0, and the absolute value of 3 is 3. Now we're going to calculate what's called the average deviation of the mean, or the ADM. And we find that by finding the average of those four absolute values that we just calculated. So now we're going to find the mean once we've taken the absolute value. We're going to add 2 plus 1 plus 0 plus 3, and we're going to divide by 4 since we're finding the average. 2 plus 1 is 3 plus 0 plus 3 is 6. Divided by 4 is 1.5. So we've learned the range as a measure of spread, which isn't a very good one. We've learned the interquartile range, which is a measure of spread we use with a skewed distribution. And now we've learned the average deviation of the mean. Why not stop here? Well, there is another measure of spread that is used widely across the world that's called standard deviation. And so we need to move further because that's going to be something that is used a lot in this class. Most commonly used in the real world. I'm going to stop here. We're going to head on to the next video for more.